Example 6. In this example, we're going to determine the slope of the tangent line to the curve y is equal to sine to the fifth x at x equals pi over 3. So the very first thing I do is to recommend to rewrite this problem in a more simplified way. So I have y is equal to sine of x to the fifth power. So if you notice where things go, the y comes straight down, the sine of x comes straight down, the x goes in right there, and then the 5 moves to the outside power. It really does help to write this equation out like this, because now when I go to take the derivative, it'll be much simpler. So I take the derivative using the chain rule, so I get dy dx is equal to, the 5 is going to come down to the front, times sine of x to the fourth power, because 5 minus 1 gives me that 4, times the derivative of this inside piece. So I write the inside piece with a derivative sign. So I get dy dx is equal to 5, and the derivative of sine of x is cosine of x. So 5 cosine of x times sine to the fourth x. And so now what I need to do is I need to take the derivative when x is equal to pi over 3. So I get this is equal to 5 cosine of pi over 3 times sine of pi over 3 to the fourth power. Notice that my exponent is moving inside and outside of the parenthesis freely. I kind of place it wherever it's going to be easiest and most convenient for me to do the algebra. So I get this is equal to 5, and cosine of pi over 3 is 1/2, and sine of pi over 3 is root 3 over 2 to the fourth. So this becomes 5 over 1 times 1 over 2 times, and root 3 to the fourth is going to be 3 times 3, so it's 9, and 2 to the fourth is 16. So I'm left with 45 over 32, and this is going to be my slope, and that's it, because all this problem asked for was slope.